I'm David Orr. I don't know a thing about props, so I've asked Fred Griffith to come down here from Great American Prop and essentially put a prop on. Tell us a little bit about it. Fred, you've got it.
Okay. We're at the prop company. We get a lot of strange calls about people with bolt problems and propeller problems and torque problems and lots of other things. And I think before we put a prop on here, we better talk a little bit about the nuts and bolts of it to begin with. We just took this propeller off, and this bolt happens to have the long threads, which all old propeller bolts used to have, the AN76 bolts. Over here, we have, I should have grabbed those before. Over here we have an AN76 propeller bolt, which is supposed to be, and it was shipped as an AN76, and it is, with a short thread. All these are little catches that you might have problems with along the way. This is an AN76, a much longer bolt, but it also has a standard AN length thread on it. Here's another AN76, a short bolt for a metal prop, and it also has a short thread. Depends on where you buy it and what the manufacturers put out. Here's a castle nut that you would use when you put on a propeller without bushings. Some of these extensions are made without bushings, and you have to go to a bolt with a safety wire or a safety key placed for a cotter key, and you'll have to put castle nuts on the back side. And if you do that, you'll find that the castle nuts will vary in the depth of the slots. And if you've got 6 propeller bolts, you ought to buy about 8 or 10 castle nuts so that you can make your torque work out for the right slot, because it won't in some cases. Some of these holes are different from others.
Is it acceptable to wash her up to the right thickness?
Oh, sure. There's about 4 different kinds of washers that you can put on this 3/8, 7/16 bolts. It depends on how lucky you are and where you can get them. The washer, of course, has to bear on the crush plate. And normally, if you have a little wider washer than standard, you do better, but it's not necessary. But you can do that if you want to. I just brought 4 along to show you that there are more than one size of washer for that bolt. So, with a castle nut, you're going to find differences. With the bolts, you're going to find, even though they're AN76, you're going to find differences in thread lengths, and the AN specifications are changing nowadays. You may even find a bolt. I found a number of them that are really not true. They have slight bends in them. Make a difference when the bolt goes in the hole. Also, make sure your threads are cleaned out. It's very important, because if you don't, it galls up the bushing threads.
What initially causes the damage to the thread used in initially a good drive lug and a good bolt?
Well, normally the drive lugs are on good. They're normally, the threads are right on spec. The problem starts, and I've talked to a number of machinists about this. We have one next door to the prop company. We use him. That these rolled threads are not on spec all the time. I mean, it's unfortunate to say that, but there are tolerances in these bolts. And if you, a lot of it, now this bolt, I've seen this bolt go in and out of here, and this bolt is on pretty good. Mm-hmm. It's not galling and it's not tearing up the thread. Some AN bolts, unfortunately, are not quite on spec, and you're going to get some galling in here. If you put a bolt in, it seems too tight, take it back out, and either try another one, or if you have a machinist that's used to working aircraft, he has a special die that'll go on there. He has different tolerances, and he knows the right one to just spin on here and just clean it up a little bit. It doesn't take out the qualities of a rolled thread, but it does clean it up to the point where it'll hit the bushings. That happened in my own airplane, my Smith mini plane. Remember the trouble I had with the bolts? I took it to him, and he said, "Hey, these threads are not on spec." And after I did that, I had no more bushing problems. In fact, I had to replace a couple of bushings. And it's a real Bearcat. Also, the bushings that come in the extensions now, sometimes the threads, in fact most of the time the threads are a lesser amount of threads in here than there are in some of the crankshaft bushings. So you have to take a look and see how deep your threads are. Bushing is trying to reduce this thread to the right size. Grip length. Well, grip length is from under the head to the top of the thread. You have to be very careful when you buy propeller bolts. We were in the bolt business for a while and got out because nobody really knows how long the bolts they need. And we've went through a lot of bolts because of it. You have to measure everything. Spinner back plates. Anything that you put on here. Front bulkheads. Crush plates. How many washers? Everything has to be accounted for. And then you want the maximum grip you can get on the bushing. You want this bolt to be flush with the back end, or maybe a thread or two on the back side. So you really have to look at it hard and do a real good job measuring. And even myself, I ended up buying 2 sets of bolts the last time. So it really is hard to do. You got to measure. Can we get down to this? You have to measure the thickness of this plate, which goes on here, of course. Then if there's a spinner bulkhead on the front side of the spinner, on the front side of the prop, you got to measure that. You have to measure the, let me move this prop a little bit here. You have to measure the thickness of the crush plate. Now some crush plates on the larger engines are another 1/8 of an inch thick because of the horsepower involved. So, and then you want a washer under your bolt head so you don't dig up your crush plate. So you got to measure all that. It's all important, or else you can't get, or you won't end up with the right length of bolt.
If you have, let's say for instance, just a slightly longer bolt than you want to use,
Okay, it's okay to wash it up.
how many washers up can we go?
I've gone up to 3 and doesn't seem to make any difference, but I don't think I go much more than that. I'm talking about standard AN washers.
Right. I've seen as many as 6 on Dick Rutan's propeller.
Well,
under a head.
that's a matter of choice of the individual. I mean, you don't even want an experimental airplane. I just don't think these are at least a 1/16 of an inch, and when you talk about 3 of them, you're talking about 3/16 of an inch, and 6 of them, you're talking at 3/8 of an inch. I think that's a little overkill myself. But if you give yourself a little bit of an allowance, you got room to move and vary things a little bit. I have one prop's a little different thickness than the other one that I move on my airplanes when I'm changing props, and I have a little list on there that says this prop takes this many washers and that prop takes that many. As it turns out, it's 2 on one prop and 1 washer on the other prop. And that's where you should get it down to.
When you're running a bolt through the propeller and it comes out the back side of the bushing, what is the absolute minimum that the end of that bolt can go to the back side of the bushing? Must the bolt go all the way through the bushing?
Well, it has to be, in the machine business, you have to be in the threads, the diameter of the bolt.
I see.
Because that deep would be the minimum that you'd have to be in that bushing. And I think you need a little safety factor on that, at least a thread and a half. And the safest way is to have the bolt flush with the back of the bushing, or a thread and a half out the back side. That's the safest way.
Mine's the minimum right there.
Well, minimum's okay, because you know that you're over the minimum for grip strength. Grip strength is the diameter of the bolt in the thread, in any thread. That's where you get. If you any less than that, you're not getting the compression that you need on the bolt.
Fred, you've told us about bolts. Tell us about bushings a little bit. What are we looking for in those?
Bushings this is about the minimum you want to have in a propeller wing. That looks to me about a 1/2 inch. I know some people run them at 3/8, but that's a little bit short. You can get longer bushings. There are various sizes.
You mean 1/2 inch out from the plate?
Yes, 1/2 inch out from the plate. In other words, this is what really drives a propeller right here. These are drive lugs, and they turn the power into the propeller. The bolts hold it in compression, hold it on to these, and these do the driving.
All right.
So, and there are various sizes. Not to be commercial about it, I'm not trying to be, but like on the ground power units, when you convert those over, you can buy extra long bushings. So you put the reinforcing plates on. Aircraft spruce has extra long bushings. Ken Brock can make extra long bushings. There are people that can do it if you feel like you don't have enough in it, but I feel like 1/2 inch is a minimum to drive the propeller. And this is about normal right here.
Does the bolt itself also drive the propeller, or is it just to hold it on?
The bolt holds the propeller on. These lugs drive. Oh, there's a little bit of driving. There's a little bit of, you know, if you could minutely see it, you would probably see a slight bend in the bolts under full power. The bolts do get some torsion at the outer end out here, but the main drive lugs are these right here. That's your main horsepower. Your force goes right through these drive lugs into the propeller. we were talking about measuring things and so forth. We gotta slip this on here now. Anything you put on this plate. Now if there's a speck of paint here, or anything, if you leave it there, if you painted this on one side and they're flaking off, or maybe a little place here, that prop's going to be out of track because the prop tip is way out here and it causes a diversion. You know, it's quite long moment arm, so this should be nice and clean, standard all the way around, nice and flush. If you don't do that, you're going to have a tracking problem. If it's soft, you can crank on a prop a little bit on torque and pull it within the track. You can also twist the prop a little bit. I know that I had a painted back plate, had paint on, and started flaking off because of taking the propeller off. And because of that, I couldn't get a good track. So when I cleaned it all off, repainted it, worked fine. So I didn't have any problems. So with that, I think we'll put this back on.
And you should put this thing on exactly the same way each time, right?
Oh, sure, and mark it. Now, I noticed this one didn't mark. Rattan's, let's see, Mike Melville's marked with an X. He has an X on here. You also want to check this and make sure that nothing's on here that's going to cause this prop to be out of track. For sure.
Thin misted in wrong, I don't think it's thick enough to cause a problem.
But there are, like I say, if you have something painted on one side, it flakes. I had some pretty heavy paint on one of these. It flaked off on one side, not the other, and I couldn't get the prop on track. Bert was giving me a foot saying the prop's perfect, and I said, I won't track. So that's what it turned out to be. Let's get a look at the propeller here. When before we ship a propeller, the last thing we do is we rebore these bushing holes and the bolt holes to take out any finish and to get the prop as close as we can to the tolerance it's supposed to be. However, because of moisture in the air and different weather in different parts of the country, this prop may swell. And these holes may not be right on tolerance. We chamfer the holes so that the bushings will go in easier. If this prop has beeswax or ski wax on it,
We use ski wax.
well, that's fine. It's a good hard wax, and it's not going to. You can see this prop's been running on an airplane. There's a lot of heat comes through here. Transfer, even with an extension, there's a lot of heat transfer. So you can see right here the wax is still here, just a few flakes of it. That's a good idea to do that. People that live in the eastern part of the country, and some probably will be seeing this, when we ship a prop and it's in UPS for 5 or 6 days, and it's bad weather and raining back east, these holes are going to be tighter. But we don't really know how to control any better than we do. We do that the last thing before it goes in the box, and I don't think we can control it any better. But if you're taking, wax them up a little bit and be very careful when you pull them down, they'll fit perfectly. If you do have to you feel you got to rebore these holes, you got to do it with a boring bar, a counter bore, because you got to have a guide in here. If you try to shoot these holes and ream them without a boring bar with a guide, you're liable to get these holes off or get them a little crooked, and then you'll have more trouble. This hole should stay on tolerance. And these holes are also kind of a little chamfer on so that the bolts are doing a little better. And how was this on here? Remember how this was? Turned it that way so it's down probably. We're going to try and put this on the way it came off. We number the blades 1 and 2, and I'm going to set this on here like you'd normally set. This is going to go on pretty easy. And you're going to get something in here to hold it.
One thing we can do is check the backside marks and just see what happened here as far as the breaking off.
Yeah.
This dark mark here at the bottom in this spot.
This was
It's marked upside down.
okay.
So it'd be good to mark this with an X too?
Well, mark each component so that it lines up.
What about your spinner cutouts, Fred? Check those in the backing.
Oh, you should have a mark on everything. On my particular airplane, I take a countersink, a little call it a little punch, and I put a little punch mark on everything that lines up. I put a little punch mark here and one here and one on the spinner, and And all those little punch marks have to line up, or you can do it with little X on the prop, like Mike Melville does. He puts a little X up here. And
An X on the
and he puts an X on
the
yeah,
extension.
so everything goes back on, because it does get confusing and it will cause you trouble. Because if you start putting everything back together again, sometimes it's not going to be right. All AN bolts are not true anymore. They just don't, the quality, I'm not saying everybody makes AN bolts, is not making them right, but we're saying that they can be crooked. They can have little bends in them, and some of them do. And sometimes these particular ones seem to be okay, but sometimes they don't fit well. There's another thing, we want to make sure these threads are all cleaned out before we put them back in there again. They'll pick up a little wood on the way out, or metal, or whatever.
I imagine good propeller shops would have good bolts.
They should, but you should still check them. You should always brush these threads out before you put them back in the prop. These threads. And my friend here just brought up the fact that the propeller should go on the airplane in such a way that if you have to hand prop it, that the compression stroke is in the right place and you can grip the propeller to pull it through. As the propellers get more exotic and as the airfoils get more exotic on these propellers, you're going to find that hand propping may be a problem because the propellers are getting thinner. They're getting better, but they're getting thinner. So you're going to have to be careful with the trailing edges. That's just in general. You're going to have to, as time marches on, you want to be careful of that. But anyway, I assume that this is in the right position for
Yeah,
compression.
we got that right.
Okay, and we'll assume we brushed out this thread. Doesn't look too bad. And, that really is important because it'll gall your bushing threads if you don't have this thread cleaned out.
It's not in flat at the top. The blade's not all the way in.
No, that's all right.
Right about. That looks fairly flat.
And we're going to say that just for practical purposes that we have measured these bolts, that everything. Well, I didn't put the crush plate on here. You missed that.
I was wondering as a pilot
to
that I
say
couldn't
that.
figure it out.
We're going to assume that these bolts are the right length, that it's already been done, that we've already calculated the bushing threads and the threads here and the length of the bolt, and that it's all going to fit properly, and we're going to not bottom out the bolts. Very recently, a good friend and had a propeller, not one of ours, but not propeller's fault. It's on Long Easy near Porterville, and we just put new bolts and everything in it, and he thought it was right, torqued up just right, and what happened was he bottomed out the bolts in the bushing within probably a half a thread. It was that close. The propeller was not torqued properly, and the propeller sheared the bolts and came off in flight. He lost the spinner, the prop, the whole thing, and it clipped his winglet on the way off. Unfortunately, he didn't have any trouble. He made a dead stick landing. The airplane's okay. But that's because when he torqued it down, he got the torque on a torque wrench, he was bottomed out in the bushing. He wasn't tightening the prop.
Is there a way to tell when you are bottomed out if you've made a mistake?
You get a hell of a lot of torque real fast. But if you're that close, it's going to be hard because these bushings are very tough material, probably 4130. And you put a prop hole up there, it can actually cut a little bit of thread. So it's a very difficult thing unless you measure very carefully. It's real important to do that.
So you just have plenty of thread is what you're saying.
And a lot of times you can't get plenty of thread because they don't allow you plenty of thread like these particular bolts are. Sometimes you can't get those. In fact, that bolt there is not an AN76, which is what most people would use on this, so they can safety the heads more easily. Let me get the rest of these bolts here. Get these in here. Another critical part of putting a prop on is how you pull a prop down. Some bolts will always go in easier than others, and that depends on how well the bolt's made, how the holes are reamed, there are a lot of things in the trouble. I never use a torque wrench to take a bolt down initially or take a bolt off. I only use a torque wrench to torque with. So I use a regular socket and let's see if we get these started here. I say torque wrenches, I don't beat them up at all, they're too expensive.
Well, just like a head gasket on a car, do you have to do them in a certain pattern?
Diametric.
Do you have to do it while you're tightening as well as torquing, or
Yes,
just?
you do. So the prop, especially a brand new propeller, because it's not going to want to go on just right. It's going to be bulky. It's going to want to.
Just beginning to come in.
Okay. Now it's just becoming, it's starting to go in there, so I want to make sure this one is in the same position that one's in. If I make mistakes, tell me. I do this all the time, but it's absolutely important to take these down on opposite sides. I'm not even sure that one's going in, or maybe
It's not. We might have to give that thing a wrap.
I don't want to hit those too hard either. When it's getting ready to set into the bushing thread, if you get after it too hard, sometimes they just won't take it off. Not sure that one's going yet.
How much gap you got between your propeller and the drive place on that side?
More than I have on the top.
You may have a maybe cocked
Maybe
off a
slightly
little bit.
cocked a little bit.
How's it left to right?
Better.
It's got to go this way. Just a tad.
We'll try one over here.
Many times I've taken gotten five of them to start, taking them almost down to the point where I started to pull the propeller
That's
in.
absolutely true.
And then the sixth one will not go.
And if you have that little galling problem we've been talking about, it won't start well. And you got to back the bolt out, clean up the threads, and start that bolt again. You should never have just 6 prop bolts. I always want a spare. So we just shipped some bolts to Sweden. We just shipped some bolts to Africa, and those fellows asked for 7 bolts. Always. They know better.
I'm sure they can count over there.
Yeah. Be surprised you can gall one up if you're not careful, especially if you don't clean the threads when you take it out. On the market some years ago, maybe 10 years ago, a whole bunch of bad AN hardware got on the market, maybe 15 years ago. A lot of it's still out there, surplus. I happened to work for Pacific Airway Corporation during the 60s and early 70s, and we had to dump a whole bunch of AN hardware that was bad, out of tolerance. And that's still available as surplus, though, it's unfortunate. You never know when you're going to get it. We buy our prop bolts from Aircraft Spruce. Again, it's not a commercial, it's just to say they have it's maybe one of those bolts we're talking about. So we switch bolts and it worked fine.
I assume from what you've said that all the bolts have to be the same.
Yeah. Well, you can get away sometimes. I put different length bolts in by using being stuck somewhere and use a couple of washers. Just gotta make sure about the thread grip. So if you don't get a situation like we talked about, bottoming out a thread, in the threads of the bushing or something, and not getting the torque on the propeller. You doing airbags? Okay, these are almost down.
So what you're trying to do right now is just bring the wood down to touch.
Right, I'm just bringing it to where I'm going to go right to my torque wrench. Set the torque wrench at 15 pounds. That's what FAA says on a wooden propeller, 15 pounds and 4 pounds to track. So we're going to go here and pull this propeller down to 15 pounds first. And we're going to go diametrically so this propeller pulls down nice and even. You can feel it starting to get tight, and then I'm going to move over to another set of bolts until it just starts to get tight. It's starting to tighten there. I'm doing this a little faster, running out of light. Bolts here. Alright, now we're pretty close to being torqued. Now I'm going to torque this to 15 pounds, this bolt. There's the clicker at 15 pounds, and I go to the opposite bolt. There's the click. Now move back over in this area, and I'll go to 15 pounds. bolt here and 15 pounds. It's opposite to the other bolt. We're going to need something to track with.
Broom handle?
What?
Yeah, I think I have one in the office here.
Okay, we're torqued there and we're torqued here. Now, because we know that this propeller will take quite a bit more torque, I'm going to go up to the 20-pound limit, which we suggest.
And I'll get you something to track with.
Something to track with, and then we're going to try to track the propeller, make sure it's dead on track at the tip. Okay, opposite side again. Click. Click. Opposite again.
Will any torque wrench work on this kind of thing?
Any torque wrench, as long as it's accurate. This is a spark plug torque wrench. I happen to like it. It works very well. Now this prop is torqued to 20 foot-pounds, and we torqued opposing bolts, and it's plenty of torque for the propeller. It should be just fine the way it is. Now we have to track it and make sure that it's on track at the tip.
While we're here looking at this, what about the backing plate? You said some people have even installed them without the backing plate. What happens?
Some people leave this off. They don't understand what a backing plate is, and they put a big washer on there, and they just pull right into the wood. They don't know that they have to have a crush plate, which is what this is. And higher horsepowers have a heavier crush plate, which we have. Yeah, but get me that one, Bert, over there. This engine's, what, 118 horse, so 235. As you get up into the higher horsepowers and bigger propellers and bigger bolts, recommend a larger crush plate or heavier crush plate. And these are the two sizes. This is what we have on here right now, the same thing. And as you can see, this is for anything over 120 or 118 horse. You should have this crush plate. This goes for like the 0290, the 0320 series, and the 0360 series propellers. Depending on the hole size, some bolts are larger on some engines. That's a matter of the engine type and the dash number. But you have to have a crush plate, not just washers out. We got a prop any other day that hadn't had a crush plate. We just had somebody just put washers in a bolt and put it on. It's incredible that they would do that, but they did. So I'll give these back to you.
If I wanted to check the torque on those nuts, would I have to loosen them up and re-torque them?
No, you
Can I torque them again?
No, you wouldn't. You can go right back to it and see if it's there. If you want to make sure the torque, you can back them off, but don't back them off with a torque wrench. Back them off with a regular wrench and then come back on with a torque wrench and pull them down again. Now, I went around these at 15, then I went around at 20. There's really no need to do that. But if you wanted to, you could do that.
All right, when's the next time we torque them?
If this were the new airplane, new propeller, first flight, you would torque it after the next flight. The first flight, you got to come down because there's a lot of heat generated in here. This propeller settling in. It has a finish on it, which is going to compress, and you want to make sure that you get back to that.
All right, and then what's the rest of the schedule from there?
The next time is 10 hours of flight time, and come back and check the torque again. You really don't have to do much to it. If you just take the safety wire, all you got to do is get your torque wrench out and check it. It's real simple to do, and safety doesn't take that long. And then 25 hours thereafter. However, if you should go east in the damp part of the country where the humidity rides in the higher levels, like anywhere east of the Rockies, this prop's going to swell. Any propeller, wooden prop's going to swell. So when you come back west and you land at Mojave or something, stay there a couple of weeks, or on the west coast here where the humidity's low, this prop's going to shrink. And it's going to shrink right away from the torque values.
What about the expansion while you're there?
It won't hurt it because it's tightening it. But if you come back out here after it swells, and then when it recedes, when it dries out, Mike Millville measured his very big and in a hangar just a while back. It had been sitting for a while. It had no measurable torque. No measurable torque.
Now, if you replace the blade with the same blade, in other words, you put it back on after it's been torqued before, do you have to go through the same schedule each time you replace the same blade?
This?
Yes.
Not necessarily. On this kind of prop you don't, on multi-laminate, but you still have to check it every 25 hours. You don't have to go first flight 10 hours, and then, but go the 25 hours, that's important.
Okay.
If you got some maintenance to do and you pull this prop off, and you know what it's been doing, and you know what the torque is, so torque it back up where it was, and then every 25 hours. We've had some props come in recently where they hadn't torqued the airplane 160 hours. The bushings were 2 diameters, and the prop sheared 5 bolts, and the man landed with 1 bolt on a long easy on an 0290 engine, being held on by 1 bolt because he didn't torque it. He didn't torque it, and it got loose. And that's just one of the stories. There's a lot of them. We won't. We ready to track?
Yeah, get your weights set up.
We're not going to hear too much on this. What you're going to be doing is tracking the propeller, is that right?
That's right.
What are you looking for, forward, aft, or are you looking...
We're looking for the, in our case, our propellers are tracked leading and trailing edge, but however, we track the leading edge tip on this propeller, where the tip itself on the leading edge side, both sides, the propeller is going to be in track. FAA says 1/16 of an inch is okay. We think that's not close enough, but it'll do. However, you try to get as close as you can. And I don't know where this prop was before, but now you can do this 2 or 3 different ways. You can do it with the ground, something on the ground to run the prop by it, but then when the airplane moves, it could be off of track. So the best thing is, just like this rig, something tied to the airplane itself that can't move, so that you can take the propeller by a tip. And I'm going to pull this propeller through. The mag switch off. And you don't want to pull it through the first time. It might be out of track. If you do, you might skin the propeller up. So you want to come down real slow on it. This propeller happens to be dead on. It's less than a 30-second tolerance on this propeller. So now we know we're tracked, and we're glued to the airplane itself, so
you don't track by turning the engine on like I assume.
Oh no, you track it right here at the tip of the propeller with a fixed object tied to the airplane.
Okay.
Now this propeller is in track, and the only thing left to do with it now is safety the bolts and put your spinner on whatever.
Did you bring it up from 15 to 20?
Yeah, I brought it from 15 to 20. I put it down to 15 first, and then I go around and bring it to 20. I just do that as a force of habit. Like I say, the FAA says 15 pounds on a wooden prop and 4 foot-pounds to track. If the propeller is set up right, it should not be out of track. And that's why it's so important to have everything clean underneath here, so it won't be out of track.
What do we cut for noise here?
The propeller tracking has nothing to do with engine mounting, not at all. The propeller is tied to the crankshaft. The propeller plane tip to tip should be exactly the same regardless of how the engine's mounted. The only thing that could make a possible difference would be if the face of the propeller were not true, or if there was some object or some piece underneath of the extension and underneath of this plate caused the propeller to be off on one side or the other. But if all this is clean and these surfaces are true, this propeller should track the same on both sides exactly. If it doesn't, going back to the FAA, CAM 18 says you're allowed 4 pounds to track. In other words, you can put 4 pounds more torque on one side of this prop, on these 3 bolts, than you put on this side. And that should maybe straighten it. That's what they say.
You mentioned also putting something on the aluminum to protect it from galling when you put the blade on.
Well, we noticed here on the back plate of the spinner there is a little bit of galling because of the finish on the propeller and what have you. A real thin piece of vinyl, peel-off vinyl like they use on shelves in kitchen. Not the heavy stuff, but the real thin stuff. A piece of that on there cut out to match your bushings here will stop that. It'll get dirty and your prop won't. You know, it's a matter of aluminum against a finish. With metal propellers, you have a crankshaft that is steel and a propeller that's aluminum. They put a piece of phenolic on there. It's a real thin piece of phenolic material to stop electrolysis, and it's the same kind of thing. Only here you're just trying to stop the galling. So the only thing left to do with this prop, I say, is safety the propeller. 2 bolts, 2 bolts, 2 bolts. And they're safetied so that if one bolt should start to loosen, it will tighten the other bolt. That's how you safety it. These bolts are put in clockwise. If one of these bolts tries to unscrew or tries to loosen, you want it to tighten the other bolt. That's how it's set up.
You got the wire to do it here?
Yeah, I got the wire. Except what size wire. A lot of people use 032 wire on propellers. That's not acceptable. It should be 040, 041. And this happens to be 041. And it's the right size. The other wire is just too thin. There's too much horsepower back here to be fooling with a small safety wire. I'm just going to cut a piece of wire here and do one of these. Now this is not an AN-76 prop bolt, so that means we don't have the advantage of having more than one hole. We can't just safety any place we want on here. We have to, we're going to have to safety this with whatever we have. I'm going to safety these two together, so some people safety different than other people. I can do this one of two ways, I guess. We want to safety this so if this prop bolt starts to unscrew, it's going to tighten this bolt. So we'll do it this way. It really doesn't matter.
Agreed.
I don't have safety wire pliers. I don't figure I need them. I've been doing this for a long time, so I just do it by hand. I can do it almost as fast. Let's see. If that one starts to tighten, that's going to be not good. Well, we might be able to do that. I'll have to see how this looks first. That's the advantage of AN-76 bolts. You got more than one hole in there, and you can really line it up the way you want to. You don't have to fool around with the holes. And there's a deal about going right hand, left hand. It really doesn't make any difference. I always put the wire underneath, so this time I'm going to go left hand. It really doesn't matter.
But you said you should use some sort of pliers. What is that for the beginner? What are you?
Safety wire pliers, they spin this on for you. This is really not set up right. If you can look at this, if this bolt started to loosen, it would eventually tighten this one, but not soon enough. So this, I pulled it, the hole was not quite lined up properly. It's going to cost us a piece of safety wire too. You can never use the same safety wire over again. Once you've done this to it, it's all over. See, that was a mistake. Now we can start over again. You off? Yeah, okay. There really is an advantage to those AN-76 bolts if you can get the right kind and the proper thread length that you need. There's nothing you can do when you're safetying by hand too. You can take the pliers, and after you get a few twists on it, you can go down here and lock that in a little tighter like I just did. So that helps a little bit on that end of it. These are so close sometimes, it's hard to... Anybody watching this? This came out a little bit cattywampus, but not having the AN-76 bolts will do it this way. The point is that it's you up later on. Now that's pretty hefty with that 040 on there, and that'll take care of it. That's probably all we need to get on tape.
Great.
We'll have to do the rest of it.
How about the prop cover?
Say again? The other thing about spinners are the air on a pusher like this. All the cooling air from the engine, the hot air is coming out here. You have the airflow around the airplane, and the more laminar you can keep this airflow here, the less disturbance you're going to have in this area, and the more efficient the prop's going to be. This area here and this spinner should really be covered up, because that can cause some trade runs, and even this should be covered. It should have as tightly a cowled prop as you can get, except some people get a little over-ambitious and they end up cutting the propeller here. And as the airplane moves and shifts over a period of time, the spinner eats into the propeller, and we have a lot of that coming in for repairs and stuff. So you don't want to get it too close, but you just want to get it reasonably close so that you have a good airflow pattern around the spinner. And that's about, and if your spinner tracks true, you ought to have somebody watch it when you first start up your engine to make sure this thing's not wobbling like hell, because if it is, you're going to lose it in the air. That happens too. They crack along these lines right here. So, first time you fire it up, make sure you got somebody taking a look at it and make sure your spinner isn't going to give you a lot of trouble. That's
Well, thank you, Fred, for doing that. Continue in the classroom.
All right.
Those are the best
As
kind.
far as I'm concerned, your questions are always the first or out of the...
The only stupid question I know of is if you know the answer.
Well, if you've just
Or
got
the one
the
you
answer.
don't ask.
If you guys have asked some good, cogent questions of him in break and you've cheated, now let's do it again. Because I didn't hear the answers and I don't know anything about props. I keep telling you that.
I got a stupid question.
Okay, let's start it with that. Do you want to do an introduction again? I think we should do a little bit more.
Go ahead.
Are you ready to start? Oh, good. We've in Squadron 2, we've just listened to and watched the tape done outside on installing a prop, and we decided to ask some questions so that other builders can hear some of the stupid questions that can be asked, but also so that we can get a feel for some of the other problems involved with props. So without further ado, I'll open the floor first. We'll talk about the tape and any questions we have on the tape, and then we'll go into other more general questions. Anybody got questions on the tape itself and what happened on tape and so forth?
You might like to review what we were talking about with the thrust bearing pulled in and out.
Okay. We all know when we're fooling with these engines, if you'll take the prop and push in and out, there's end play in the crankshaft, okay? Up against the bearing. You should push that one way or the other, the track. You shouldn't push it in and track one side and pull it out and track the other side. Make sure it's either in or out.
Okay.
That's a point that you brought up, which is very good. And what was the other one you asked me about?
We were discussing on some propellers, not yours, but for one of your competitors, they were not finished completely on the bottom,
Okay.
and we had to take a Momex bar and,
All right.
polish it down.
Here's, with our propellers, after the propeller comes out of finish, we track both sides of the hub again and scrape the finish, should it have any irregularities, and then we compound that so we don't have to redo it again. So the prop is finished on both sides. If a prop isn't tracked on both sides after it's finished, it could very well be out of track because the finish can be thicker on one side of the hub than the other, and it could be out of track. And that can be a problem. I've seen props with pieces of a paper bag behind them and pieces of tape behind them, and what you really should do is put the propeller on a surface, if you got a way of doing it, on a flat surface and scrape that finish until that prop tracks properly. That should be done to factory, and there's no reason why it shouldn't be done. I know that I can only speak for myself, and we do it that way, and that's the only way you can get a true propeller. You have to get all the surfaces true, even after the finish is put on, because you don't know how thick it is or where it is.
You were talking about the real problem of changing geographical positions from wet to dry. Is anything being done about impregnating the wood around the bolts, or is there any kind of a bushing that could be put in so that the prop could be made up, torqued up, and would be okay? It would just stay okay.
Problem with wood is that it does still carry a moisture content, which it has to. These props probably about 7 to 12% moisture, and moisture migrates, and you have engine heat transfer through the crankshaft into the propeller. As you all know, if you heat something up, when you cool it, you draw the moisture. So the prop's constantly changing. That's the reason why you have to keep a wood propeller horizontal on the airplane. If you turn the prop up on end, the moisture within the prop, regardless of what's outside, is going to migrate to the low side because it's water. There's moisture in the wood all the time. If there wasn't any moisture in it, it wouldn't be any good. So you got to keep a prop horizontal. As far as impregnating the propeller completely, I don't really believe that can be done. You can take a very thin finish and put it in the bolt holes. We do the bolt holes with Q-tips. We put a thin finish in there, and then we ream them before they leave the plant. Like say, one of the last things we do is we ream those holes to take all the irregularities out of them and clean off the finish so the bolts go through clean and the bushings. But I have not found a way to completely seal up a wooden hub And I really don't believe that you can find a way. There may be a way, but you'd have to encapsulate the propeller completely. I mean, it'd have to be dipped and squeezed, and I don't know what all you'd have to do. There's just not enough barrier between the outside surface and those bolts and the amount of finish you can get into those end grains inside those holes. Now, when you put the bolts through, if the holes are good, reamed well, the bolts present a very good barrier to outside. However, wood will pick up that moisture. If you move from 30% humidity to 70% humidity, that wood's going to pick up some moisture and it's going to swell. There's no way to stop it. There may be a way in the future, but there isn't right now.
We had a product at Hughes called Pregwood, and we used to laminate. It was wood compressed to about double density,
I have some of it.
and we used to laminate that to the skins to give better bearing for the bolt holes where they bolted on.
Right, I've seen some of that wood.
Could a product like that be bonded into the prop?
Probably. This is getting close. These props now, these blanks that we have now is maple with phenolic glue. They're bonded up, pressed up at 300 degrees with phenolic glue. There's not as much compression as you're talking about, but there is some compression. And if we went to 16th laminations, there would be more compression and more glue penetration. However, you got to remember, in the industry, we're trying to keep props. These props are still under $300. I mean, under $400. And if we start that, right away we'd have props over $400 right away because of the cost of laying them up. But you're right about that. I wish we could solve it. The more laminations you get, and the thinner laminations, the closer we are to what you're talking about.
With a greater percentage of plastic instead of wood.
Right, exactly. But we still got a wooden prop.
Well, tell us a little bit about a couple of things. One is the putting a prop on end, first on the plane and also on end while storing it. Tell us why that's bad.
When it comes in the box, and when you receive a prop, if you're not going to use it right away, lay it down in the box. It's perfectly safe laying flat. Or hang it on the wall. Just take it off and put it on a peg or a nail, but keep it horizontal. Because the moisture is going to migrate to the low end. The moisture within the wood itself. Doesn't matter what you do. On your airplane, keep a wooden prop horizontal all the time.
And on a long easy, particularly if you ever happen to raise the nose too high, of course, you'll
If the
ding the
prop
prop.
is sitting down like this, you're going to have broken props, and we get calls on that all the time. He said, my prior airplane just fell backwards and it broke the prop off. The prop wasn't horizontal, it was vertical. So it's a good thing to remember, on long easy, keep your prop horizontal and you'll probably save yourself, even went over it with hurt it down.
You know, some fields they order gas by putting the prop vertically, and it's just not a good practice.
It's not a good practice, you're going to break them sooner or later. It's happened a number of times.
When you put in the bolts, you know, you're putting it in through wood, which does carry a lot of moisture. Should you put a preservative or a film of oil on those bolts to protect them?
No, remember, when you're going through that wood, you're going through a hole that's been reamed, a hole that's had some finish in it, and a hole that's been reamed, and a bolt that's going to get hot. Remember, it's going to transfer heat. And if anything else, it's going to harden up the areas around those holes. You don't have to worry about that.
Bolts are cad plated.
They're cad plated and irrigated, most of them.
I've heard when people are talking about the props, they all talk about, oh, I've got a 6870 or a 6568 or whatever. What does all that mean?
Okay, the first number is the length or diameter. The second number is a theoretical pitch in inches. And that can vary with manufacturers. It's a place where we measure the pitch of the blade. That is, the old story goes, if it's you said 68 pitch, theoretically when the prop turns a revolution, the airplane moves 68 inches.
So essentially it's a 68-inch bite
That's right.
per revolution.
Exactly.
Was that, is there a reference on the zero lift line or on the, just on some arbitrary?
Well, right now, on these particular propellers, and the long easy propeller we sell, we measure off the flat, which is not the true pitch of the airfoil, but we measure off the flat because it's easy and it's easy to do. We don't have to go to the cord line of the airfoil, we just measure the flat. You'll notice that our pitch numbers are probably down 2 or 3, is that right, Bert? 2 or 3 inches?
About 4 inches.
Okay, we're down about 4 inches from some other, like Ted Henderson may make a prop, or Bruce Tibbs, and you'll see the pitch number higher. It's only the way he measures the pitch. The props, if you put them on the airplanes, are pretty close, just where you measure that, and the station you measure that.
Wasn't it standard to measure that at 2/3 out?
Not necessarily.
Doesn't it constantly change as it goes from the hub out to the
We
tip?
measure 70% at about
The
70.
blade's supposed to advance the same amount.
Yeah, I know, I understand that, but I'm talking about measuring, the pitch is all different,
No, the pitch should be the same any place on the
Isn't it 2/3 out and isn't that supposed to be?
We
standard?
measure it where 70.
2/3 out, 70% of the blade is the normal point at which they
That's
check
right.
it. It's not necessarily any different in pitch in inches, but the angle will be different.
Right. The straight helix. The helix will be changing, but the pitch will be the same.
How would we know what to order?
We tell you what to order in our order form right there. We have all this figured out, and it says right there, long easy, such and such a horsepower, such and such a diameter, such and such a pitch. Now that's an average. Some people do different things and want slight variations that we try to comply with.
It used to be the same prop for the cozy, huh?
Yes. We improved the cozy's performance a great deal, and in fact, that's what they use on the cozy now. Is our propeller.
You know, one point when if a guy's putting a prop on an engine that's maybe the first time installation, if he has a problem with the track, it might be wise to check the run out on the hub of the prop, especially with the used engine.
You buy used engines, you could very well have a bent crank flange in your crank. Remember, Lycoming flanges are soft and can be bent. Continental flanges are hard and can't be bent. If they're bent, you're finished. Lycoming flanges have a run out and they are soft. They can be worked. So it's possible to get a Lycoming flange that has a tweak in it. And that could be your track.
It won't take much either.
Not much. But you're right. The Lycoming flanges are soft and could be off track.
You mentioned while we were at dinner tonight something about your policy on when we break a prop in upper Ypsilanti. What you folks can do for a person with one of your props.
Well, normally we have a loaner in stock. In fact, right now we have two, and we try to keep them for. We have, there's SAE1, SAE2 hubs. You might buy an engine, say you buy a 0235 C2, it might have an SAE1 hub or an SAE2. That's the diameter of the bushing circle. So you have to measure that. So one is 4 3/8 SAE1, 4 3/4 SAE2. You have to call something and say, hey, I busted my prop and I can't get home. We say, okay, where are you? And what kind of hub do you have? And what kind of engine do you have, and so forth. And what we'll do is we'll send you a propeller. You can have it any way you want, just as long as you pay for it. You can get it Federal Express or as fast as you can get it, or however you want it. And you pay for that, we'll give you the prop free as long as you return the prop that's in good condition. When you get home, just return it to the next guy. It can be ready for the next man if needs it. We give that free. You have to pay all of the cost of getting it to you and back to us. And we try to keep enough props in stock. We have very easies, long easies, a combination of other propellers, Osprey. We keep for that purpose.
Of course, if you've done prop damage, you may have done engine damage. It's something
possible.
to warn everybody.
However, with a wooden propeller, most of the time, 99% of the time, you don't do engine damage. That's the great part of wooden propeller. If you break one on a metal propeller on an airplane, you got to pull the engine apart. If you break on a wooden prop, just a small tweak, you can dial out your flange.
Yes, and the FAA, for sudden stoppage, you got to...
Sudden stoppage on a metal
just
prop, you
remember
have to tear down the engine. Sudden stoppage on a wooden prop, you don't. It's a hell of an advantage. I'll show you another advantage while we're talking about that. This is a wooden prop that we damaged on purpose. And you can see this is really whacked good. That's quite repairable. In fact, if you look closely, can you see this? Right here, this tip's been repaired with a worse bang than this right out here. It's already been repaired, and we did it on purpose to show you that it could be done. This is ready to repair, and this is quite repairable, even twice that big. They could never do that to a metal propeller. The only thing that you can't do is repair a broken tip. The airfoils are too thin, the centrifugal loads are too high, and I'll show you an example of a long easy prop. I'm showing these to you so you know what when you call up with a problem. This is a long easy prop, a standard 62-62. You broke the tip off. That is not repairable. If he had taken a big chunk out of here, it would be repairable. But this is, you can forget it right there. It's unfortunate. It's right at the tip. There's the tip of the prop right there. Just took off that trailing edge.
Can you shorten it up a little?
You could shorten it, maybe you get home with, you could cut an inch or two off, but you have a RPM change and a little loss of efficiency.
Have to cut off both ends.
Yeah, you have to cut both ends off. Measure it real good from here out.
I have a question on dynamically balancing. If you put a starter gear on your engine and a new propeller, should you dynamically balance that?
We balance our propellers as best we know how. We blade balance, we
No,
hook
but I mean the
balance.
complete assembly.
I suppose you could. A friend of mine who owns West Coast Propeller Service, Keith over there, he's the owner of the place at the Burbank. He has a place that dynamically balances propellers. They spin them. I really don't think that's necessary in wood. Wood is so inert and it's not frequency sensitive at all. They're dead smooth across the RPM range usually. From 0 to 3,400, they don't make a sound. They just sit there inert. That's a great thing about wood. You can't get that with metal either. They have some resonant frequency problems with metal props. And certain RPMs you can't run them in usually. And with a wood prop, that's never a problem.
Could you just go through what you do to make a prop from start to finish? What you start with, what materials, and so forth?
Okay, we start with, their blanks are now certified. This is Canadian maple. This is just an example of a blank that's been cut into a VW size. But we get blanks pre-made or pre-laminated by Birchwood Manufacturing up in Rice Lake, Wisconsin. They are certified, FAA certified blanks. It doesn't mean prop certified, but the blanks are. That's stage one, you know. They're shipped to us, you know, on pallets. This goes into, each blank is drilled on the end. Bert sets them up. He has a special way of lining these props out so when you go in the machine they cut absolutely true. And we have a master blank which is half of a propeller, oversized, which is like this only it's bigger, so that the tracer wheel on the machine goes over does not cause flexion because the template is so much thicker that it'll cut this very true without flexion. And it's a spiral cut. It starts at the tip, it spirals, you can see the spiral marks here of the cuts, spirals to the hub, the machine resets and goes out and makes a finished cut. This is the finished cut. It's not done by a long shot. Then this goes to, it's turned around in the machine, the other side gets done. In other words, the prop will always be the same one side to the other because it's cut on the same template. We only cut half the prop at a time. The master template is only one half. These blades are dead on side to side. After the other side is cut, the ends get trimmed. They go to hand shaping. A long easy takes about 4 hours of hand shaping. With protractor, we check airfoils with hard templates every 3 inches. We don't allow the tolerances like the FAA gives you. They'll give you a tolerance of, I think it's 2/10 of a degree, which they figure is close enough. We don't. We have 0 tolerance. Black protractor. And these are hand shaped to that stage. Hubs are drilled according to whatever hub goes into a particular propeller. Manufacturing records follow this propeller all the way through as the data on in our order blanks. You can see all the stuff, the SAE 1 or 2 hub and or a VW hub or whatever it has to be. And after it gets to that stage, then it goes for track and balance. And you might notice some of our hubs. We will not slug a prop. You can slug a prop and balance it. You know what I mean? By drilling a hole in it, putting a piece of weight in there, a metal slug or lead or something. We won't do that. What we do with the prop, we'll even distort the hub to get the balance if we have to, rather than slug it. We don't think that inertia of a slug is a good idea, and we know it really isn't. So you might find a hub sometimes not quite true in certain places. It doesn't hurt a damn thing because it's just the center of the hub is all. It's just it's quite strong enough. It has nothing to do with the performance of the propeller. But sometimes the wood is a little different one side to the other, and the weight's off a little bit. Maple's pretty heavy. After it's tracked and balanced, it goes into an extensive 11-day finish process. These blades are all Kevlar. 70% of the blade from the tip end.
You've got one there with Kevlar on it, right?
Uh-huh. I'll show it to you. This one here, you can see it pretty good. This is one of the older props, not one of the newest blanks, but you can see the Kevlar. It's very distinctive. It starts here and goes out to the tip, and it's completely wrapped in Kevlar. That process takes, and the final finish takes 11 days. Now this Kevlar is completely wrapped around this propeller. The compound curves and Kevlar do not get along very well. And we have to go through a lot of problems to get it to stay where it is. We have to do one side one day, one side the next, and it gets 5 fill coats because it's very rough. And we fill it up with 5 fill coats, sanding between coats every day. Then after that's smooth, then it gets 3 finish coats, so it has 8 coats on it when it comes out. And that process from beginning to end takes 11 days. Tip paint the last day, and of course...
What's the advantage of the Kevlar?
Well, one advantage is this prop right here. This is an experimental propeller. One that was on Tom Williams' airplane. You may know Tom Williams. He was flying it around the country for us, testing it out. It's a new, what they call ARA section, brace design. It's a very difficult prop to make, and we only made one to see how it works, and it did improve performance some. It's too hard to make for production. It cost too much. But anyhow, this is a regular long easy with the 235, 118 horse. He was cruising somewhere in South Carolina. He'd been on a long cross country. His left gas tank cap came off in cruise. He's probably doing 175 or 80 miles an hour, and went through this prop. Main gas cap. Because of the Kevlar, this prop stayed together. It probably would not have without the Kevlar. It would have probably split all the way. In fact, he didn't know what happened. The gas boy told him when he went to fuel the airplane. But this prop stayed together because of the Kevlar. See, normally that would have come off there without the Kevlar. You can see where it tore into the Kevlar here. This Kevlar is on this wood so well and bonded with polyurethane, you cannot tear it off. We have tried, we ran all kinds of tests. You have to sand it off or scrape it off. It won't come off. It's bonded so well.
It also helps with minor dings?
Oh, sure it does, yeah. Now, we don't claim this is the best in the world. We're working on erosion protection beyond the Kevlar. It does do very well, and it's quite easily repaired. If you have a prop for a few months or whatever length of time, and you start getting a few little dings in it, the worst possible thing you can do is not fill up the holes. If you get a rock and you hit it, that can happen to any propeller. You want to take some epoxy and fill up that little hole, smooth it out, whatever. Keep that hole closed. Otherwise, keep the prop sealed from the elements. That's the most important thing. And another important thing that most people seem to ignore is that the slicker this prop is, the less hits it will take, and the less erosion you will get. If you get a good hard wax on this and keep this thing waxed all the time, it will take a lot less beating because the air over the prop will stay laminar. It will stick to the prop, and it's like a little cushion on the surface of the propeller. And this prop unwaxed would take a hit here, and it might be, say for instance, it would be a 32nd of an inch deep. If it were waxed, it would probably be less than a 64th. It makes that much difference. Just keeping it slick. It's the hardest thing to tell people about keeping their props slick. It really works.
Are the veneers sliced or rotary?
These are peeled. These logs are heated in the steam room. They're not submerged. These are heated logs in the steam room. We've been through the plant at Birchwood up there. It's quite an interesting process. And the logs are peeled and dried and trimmed. And when they're all dried and trimmed and graded, and then they go into a process where they're glued on both sides through a special machine and put together in large piles and then pressed to a certain pressure and about 300 degrees. And they're cured in there for some time. It's quite a process, and it really makes it tough to develop. But the Kevlar really helps a lot. We're working on erosion protection beyond the Kevlar, and we feel like next year we're going to have a very efficient system.
Do you have some suggestions, on the subject of erosion as far as, when flying into rain with a prop like that?
Okay, you should always reduce RPM in the rain. If you reduce RPM and airspeed, you're going to reduce the damage to the propeller. Today, in today's market and with propellers, a propeller is only as good as the finish on it. And that's what it really amounts to. Even with the Eurolite leading edges, and they're quite nice and they work well. Bruce uses them and Ted Henderson uses them, and they're fine. But the protection is the protection has to be back about an inch or thereabouts to really give you good protection in the rain. You should always slow down with a wooden prop, because you're going to, I've seen metal props that were damaged a great deal in rain.
And how long do you, what would you say?
I'd slow down, it's about 60%, 65% power, at least I'd run back 2350 or something like that. That's quite adequate, but get the hell out of the heavy rain, you know. Rain's hard on an airplane. It's not only hard on propellers, it's hard on a lot of things. Hard on paint. I'd rather fly my mini plane through some rain once, and I don't think I'll do that again, because it really did hurt the paint. It's quite obvious that it was, and I had acrylic enamel on it, which is very tough stuff.
How do the props you make differ in, not quality, but construction from the other two that are Rutan talks about? Tift and who else?
Bruce Tiffs and Ted Henriksen, they're good competitors of ours. They make nice propellers. They're still laying theirs up out of 3/4 inch wood. I think Bruce is using maple, 3/4 inch maple. Is Ted using maple? Birch? He's using birch, and Ted Henriksen? I think he's using birch. Both very good woods. We wish we could get good birch. That's the reason, one of the reasons we went to these multi-laminate.
That's, matter of fact, that's when Freddie Griffith saw that propeller. Because I was in the back seat of his airplane when he lost a mag and landed there, and Jim helped us with the mag and getting some of the parts.
Well, Jim Pierce is the one that lost the B&T that we had refinished, one of Bruce's props, and he got the prop bolts torqued down against the end of the thread, and it was Jim Pierce that lost the propeller because of improper torque. The long bolts, or the bolts were too long.
I think before the tape ran out, we were asking what's the best way to protect a prop, and you were going into that.
Oh yeah, the best way to protect it is not run it up static unless you have to. Make sure it's clean where if you're going to put full power on it, sitting still. The next thing is open the throttle easy on takeoff. Don't jam it all on at once. You're going to suck up whatever's there. Just open it up easily, and unless you're in a short field, you have to put it all on. And like I said, you can take off on a gravel airport even if you open the throttle slow and accelerate, and like the man said here, don't stop, keep on going. And you'd be surprised, you won't hardly have any damage at all. Most hits on a prop are on the back side of the blade, not the front, not the leading edge, on the back side of the blade. To keep the prop good and slick, there'd be a little laminar flow on the back side of the propeller, and the just not going to take as much hit or as much erosion.
Talking about polish again.
Yes, polishing the prop.
Do you have a brand of polish you'd recommend?
Not really. I just use a good carnauba. There's a wax out called Harley. I use that.
There's a number of people I've seen taxiing around with their speed brake open all the time. I imagine that's bad for cooling eventually, but is that good for the prop?
I don't really know. I don't know what the aerodynamics are of the, you have to run water tests or something on that nose wheel to see where the trajectories are. I don't really have any data on that.
Mike has mentioned to me on like a number of occasions that it's the front wheel. He feels it's the front wheel that kicks the rocks into the propeller.
Could be.
And
could very well be.
Gone so far as to, I think he tried a tire out in the front that didn't have any grooves in it because it doesn't pick up a rock. It doesn't sling it.
It may very well be true. You may end up with some kind of guard on those. Maybe somebody can come up with a guard for the front nose wheel.
Well, I left space in my nose wheel compartment to put a little fender on.
A good idea. It's always a good idea to do
There's
that.
a Canard Pusher recommendation is you put a coffee can lid down there, plastic coffee can lid.
Yeah, because you might land in water someday. Hey, water, you can't compress water. Water is as hard as a rock, or harder than concrete. Believe it or not, it is. People don't realize that, how hard water is. I was flying a Gulfstream one day. I left Indianapolis when I was flying from Disney. And we had those big turboprops on there with those big rubber boots, those electrically heated boots. Those are huge propellers. And when I went through some rain, and some fairly good rain and some bad weather, and when I landed in Minneapolis, those propeller boots were shredded. And that airplane's made for all weather, So, that might tell you something too.
Well, while we have you on tape, occasionally labels get lost and ownership gets lost. Could you say where this tape should be returned in case it gets lost on the field here?
I want to mention one thing about this. We have an installation sheet that mentions most of the things that are on the tape about putting a propeller on an airplane, how to take care of it. You don't have to buy one of our props to get it. If you're looking at this tape and you want an installation sheet and want to know how to track your prop, torque it, and take care of it, all you have to do is call us or write us and we'll send it to you.
What's your phone number?
It's area code 805-481-9054.
And if this tape turns up somewhere, go ahead and send it back to Great American, and they'll find out who owns it.
All right. We hope that this tape will get around to the anybody who wants it in the EAA so it can be shown at the chapters. And anybody has any questions, all you do is call us up.
And the address is?
The address is 1180 Pike Lane, number 5, Oceana, California. And that's O-C-E-A-N-O because nobody knows how to spell it. 93445. We'd be happy to talk to you.
Dave, it's right on this yellow sheet.
Yeah, it's on all of our
It's
lists.
not on the tape, so I just wanted to be sure it's on the tape. I want to thank you very much for coming down and sharing this with us, and I think it's invaluable information, especially for fools like me who don't know anything about mounting props. So I think a round of applause is in order.
Thank you very much.
If we come up to Oceana there, could we go through the...
Sure. We invite anybody who wants to come up to come by. Oceana Airport's 5 blocks away. If you fly in, we'll come get you.
Is that north of the airport?
Well, we're just due east of the airport.
East of it?
Yeah. The airport's right there on the ocean. And this little road comes right over a bridge, and we're right there in that industrial complex. If you have a prop problem, you want to bring a prop up, we'll call the airport and pick it up. You know, we do that.
All right. The list of things we have to cover tonight. We have about 15 items to cover, so let's go through it quickly. I'm looking, my book is the Squadron Library, for those who don't know. If you ever have a moment and you're in here and don't have anything to do, you might want to look through all the articles, the maintenance articles, rebuilding articles.
All right, Bob's Paint Finishing, I guess it's called. Bob's, so I gotta remember. Corner of 15th and Broadway in Santa Monica. Next meeting will not be here, it will be there. They have complete facilities, they're gonna have a hands-on finishing training program for us. We've got people there from DuPont, Yamron Field Specialists will be there, 3M will be there. Hopefully we're going to have the Sterling man there. We already have some of our parts, the reject parts that we weren't going to be using. But they have done some finishing on, so you can see it in stages, what the various fills and sanding and painting and so forth will be like. They offer, as a side item, they offer good courses in painting and finishing. Primarily their workforce has always been auto body. However, Bob and also the men from DuPont who are down here are very excited about the long easy project, especially when I told them how many are being built in the United States. Suddenly it's $75 a gallon, that's a major market. You know, figure what, 2,000 to 3,000 planes being built, $75 a gallon, how many gallons does it take to paint sand? And that's only the paint. We've got the primer and the finishers and everything else. It's thinner.
And they're not cheap. What is that?
So DuPont is very, very interested in this. I presented the debate about ultraviolet barrier treatment. And he said he doubts very seriously whether Bert knows which end of the spray can to insert into the hose. Because he doesn't think it's correct. However, we will have all that ultraviolet information for us at that meeting.
When's that?
That is, I believe it's the 13th.
It's a regular Wednesday meeting.
A regular
Don't go on Saturday, you'll be alone. In
Just
fact,
don't
I
come
called there
here.
on Saturdays, there's nobody there to even answer the phone, so...
Just don't
go
come
on
here.
Wednesday.
Go there. Corner of 15th and Broadway, Bob's. Big paint shop.
I'll stand if you have any questions. Get on your membership list. A couple people flopped down dollars already. What we do as a membership fee for this club, by the way, is put $1 on the table as we're leaving or before we come or whatever. When we come, so that we can continue mailings and sending out stuff and ordering supplies and buying videotapes. I'll
first of all, by giving you a little bit of background into Slick Aircraft Products. Slick Electro, as many of you have heard the name, started out as a division of J.I. Case Tractor Company in Rockford, Illinois, back in the late 40s and early 50s. And when they went to the diesel engines on the tractors, the magneto division of that tractor company was eliminated, and a gentleman that ran that division by the name of Fred Slick bought the division and bought the rights to manufacture and started to get into the aircraft magnetos. Case had previously done that to a limited extent, and he just developed that from that point on. Some of you may have seen some of the old Case mags. Some of them are still around. So in the 50s, Fred ran the division, bought the rights to manufacture, and developed the 400 and 600 series magneto. And then sold the division to Art Johnson in the 60s, and he developed the 4000 and 4100 series, commonly termed a throwaway mag that we'll talk about a little bit later. And then in 1979, they developed the 4200 series, which is the rebuildable magneto. The company was sold again in 1980, and it's still under that ownership. A gentleman by the name of Rick Sontag and some private investors bought the company in 1980. In 1984, it was made into a division of Unison Industries. It's still the same owners. It was just a division for accounting purposes and so on. We have 3 operating divisions back at Unison Industries. The first one is Unison Dynamics, and this slide is a picture of the industrial motors that Unison Dynamics manufactures. These motors are special in that they have very quick and responsive on-off systems. They're used in hospital treadmills and that type of thing. We have another division known as Rockford Metal Products. Rockford Metal Products is an aluminum die-cast contractor. They manufacture aluminum parts for Johnson and Eska motors, Sears, Counselor, the bathroom scales that you have at home, the base, the aluminum base for those are manufactured by Rockford Metal Products. They also manufacture a lot of parts for Slick Aircraft Products. They make all of our frames and housings. We have a screw machine division that turns all of the rotors and all of our hardware. This is just a slide of some of the test facilities that we have at Unison Dynamics. Slick Aircraft Products is the 3rd division, and of course we manufacture magnetos and ignition harnesses. We're a little bit unique in the industry that we manufacture about 93% of every part that goes into our products right there in-house, between ourselves and Rockford Metal Products. On the magnetos, the only part, the electrical part that we don't manufacture is a condenser, and on the harness, we turn all of the center coiled conductor, and then the wire is sent out and put on. Otherwise, all the hardware, the rubber ends and everything else is manufactured right there. What I'd like to do is just very briefly go through some slides of some maintenance things that you should know, some problems that we've had, some things to watch for. This will not be a complete presentation on how to completely overhaul a mag, but it will touch on the highlights of some of the things that you should watch out for, especially on the 0235 and 0320 engine. This mag is just more or less for interest. This is the new pressurized magneto that some of you may have heard about. Mooney came to us back in 1981, and they were having problems with the current system with high altitude mist. So we developed a pressurized magneto that helped them to eliminate high altitude mist on the new Mooney 231. We currently have approval on the Cessna 303 and the P210, the Mooney 231, and Beach is currently looking at us for the Bonanza and Baron series. This is a slide of the T100 toolkit that we manufacture there. It's a toolkit that we recommend that you use when you're doing maintenance on our mags. Most FBOs and so on have their own tools which are perfectly okay to use. We recommend this for somebody that doesn't have the proper setup so that they're not taking the mag and cramping it down with a vise and that type of thing. That's an important point because we've had some mags where they have been crimped down in vices, put on the engine, over torqued when they're put on the engine, and they'll drop off in flight. So it's very important that they're not put into a vise and that the proper tools are used.
What is the cost of your installation of that kit?
That kit right there lists at $70.
Everything we see?
Yeah.
Just the mag.
Right. We manufacture almost everything for that toolkit right there. And we have tried to keep the price of that toolkit down so that people will buy it. We feel the only way that people are going to buy it, and we know that they're using the right tools, is if we keep the price down on it. So we've tried to keep it down as low as possible to get them out in the field. Same thing with a toolkit that we have for the harness build-up. That toolkit lists for $50. A lot of guys laugh when they see this slide because some of them have obviously experienced the spring tension under the impulse coupling when they've taken it off. I would be careful, and this is the only reason I show this slide, if you've never taken an impulse coupling off and you're taking the shell off, be very careful of that spring tension underneath, because if you let loose of that thing, it could potentially fly across the room. And this is a picture of that spring. And you can see it gets wound up in there pretty tight. A couple of the slides now that I'm going to talk about especially pertain to the engines that you guys use on the long easies, the 0235s and the 0320s. Some of you may be familiar with a service bulletin that's been out for a little over a year. It's our service bulletin 7-83. Now what it pertains to is a new style bearing. This slide is the old style open face bearing that we used up until April of '82 on our magnetos. One way you can check your mag is check the serial number on the mag. Our serial numbers they're 7-digit serial numbers. The first digit represents the year. The next 2 digits represent the month. So you can look at that. Anything after 204 has got the new style bearing in it. If it's got the old style bearing, I would suggest that you comply with the service bulletin. What that service bulletin tells you to do is one of 2 things. Either take the mag off and repack the bearings and continue to do that every 250 hours instead of 500 hours, or take it off and put the new shielded bearings on, which is this slide right here, which isn't all that great a slide, but these bearings are shielded on both sides. Once you put those on, you'll never have to do any kind of lube of those bearings, and those bearings should last the life of the engine. The problem that we've had is on the 0235s and the 0320s, we have had a problem with the way the mag is mounted on the engine and the gear alignment on the Lycoming engine. It puts a torsional load on that rear bearing, and eventually it heats up inside of that, see that aluminum casting there on the bottom? It heats up inside of that aluminum casting and seizes up. And we've had probably 15, in the last year and a half, we've probably had 15 engines that have seized up, or where the mag is seized up and tore the drive gear up. So on those engines, be especially careful and apply for that service bulletin and comply with it.
What's the number of the bulletin?
Service bulletin 7-83. We were out of print on them, otherwise I'd have brought some, but if you call the number on the back of that manual, we'll be glad to send some out to you. Another design change that we've done to the mags in the last 2 years is the carbon brush. Prior to '82, we had a problem with the carbon brush burning a hole in the coil strap. So we went to a spring-loaded style carbon brush that adjusts for tension inside of the magneto. You can see the spring-loaded brush there on the right. Prior to that, we just had a stationary carbon brush. This will benefit you guys in a couple of ways. Number one, it'll save you having to buy a $90 or $100 coil. And number two, if the carbon brush should wear, prior to this you had to buy about a $65 gear assembly. Now you can pay $1.50 and get a carbon brush to replace it. After you have the mag apart, there are some things that you should inspect. we have a list in this green manual, and if any of you didn't get a copy of it, please feel free to take whatever quantities you need. There's a list in that manual that calls out for the parts that are required to be replaced only at overhaul of the magneto. These parts that we're going to see on the next couple of slides are not required to be replaced, but you should do an inspection on them. Number one is the rotor shaft, and this should just be inspected on both the magnet, which is a big piece right in front of you, and the shaft itself for any excessive wear. Also check to make sure that the shaft isn't bent in any way, and always check the threads on it. The frame should be checked again for any cracks or any abnormal wear, and especially check back, into the housing end of it where the rotor shaft turns. Make sure that it hasn't spun or anything like that, and then check the internal threads as well. On the frame end of it, again, just check the same thing that you did on the housing. All the internal threads, and check to make sure there aren't any cracks or any abnormal wear. This is the bearing cap, and again, with the 0235s and the 0320s, this should be looked at very closely. Take a look at it inside where the pencil indicates there, and see if that bearing has spun inside that cap at all. Again, if you have any indication of bearing spin at all and you haven't complied with that service bulletin, I would suggest you do it. If you have complied with it and for some reason you're getting bearing spin, by all means let us know. We haven't had any cases of that yet. But if you have complied with it and you're getting bearing spin with that new bearing, let us know. The only thing I want to say here is when you put the coil back in, and the coil does need to be replaced at overhaul, but when you put the new coil back in and you're driving the wedges in that hold the coil in place, alternate as you're putting them in. Those wedges are made out of aluminum, and if you drive one in all the way, chances are you're not going to get the other one in. And then when you go to pull it out, you're liable to break it and have to drill it out. So when you're putting that in, just make sure you alternate wedges and drive them in alternately, and you shouldn't have any problem with seating the coil in there evenly. We talked about the stationary and the spring-loaded carbon brush. If your mag has a stationary carbon brush, when you put the coil back in, that coil strap should protrude above the edge of the frame approximately 1/16 of an inch. If you have the spring-loaded carbon brush, that strap should be flush with the edge of the frame or 1/32 below the frame. And that's important because if you have it a 16th or any above that frame and you have a spring-loaded carbon brush, that coil strap will arc up against the bushing that brush rides in. So make sure that you check to see what kind of brush you have, and it calls out in this manual that I handed out exactly how to do that. On all of the internal and external screws, the only thing I want to say here is that make sure that you comply with the torque specs that we call out in the manual. Right now, for example, Bendix is having a problem with cam screws on the dual mag, and the reason for that is a screw that they have that is too short for the slot. But the important part about it is that you cannot get it torqued down to the limits, and that screw backs out. Same thing can happen in our mags if those screws aren't torqued down to the proper specs. And most of these screws have different specs, so check in the manual to make sure that you're torquing that particular screw down to the right spec. On the rotor shaft, when you put the Woodruff key on that rotor shaft, make sure that it looks like this when you're done and that it's not in there cockeyed. If it is, you probably won't get the impulse coupling on there to begin with. But if it should be on there cockeyed, that Woodruff key serves as somewhat of a shear pin, in that if that impulse coupling should ever lock up, it should be able to shear that Woodruff key, and the impulse coupling will be able to turn on that rotor shaft so that it doesn't lock the mag up and then tear gears up and everything else. So it's important to make sure that that key is put on evenly as it's shown here. I'm just demonstrating here the proper way to put an impulse coupling back together, and again you have to be careful of the spring tension. I don't know if you can see in this slide, but if you look on the shell part, which is the big part on the left hand side, can you see that little round kind of nipple there? Right in the center of the picture. Can you point that out, Dave?
That?
Yes, right there. That's the little tab on the spring, and that should fit inside of that slot. When you put this impulse coupling together, you should not have to turn that impulse coupling any more than 45 degrees to get it to lock into the ears, which is on the bottom of the picture there. If you have to turn it any more than 45 degrees, you're going the wrong way. And this is really the best way to get it back together, is just take your index finger and thumb and grab the lobes and turn it back 45 degrees, and you can see it's just about to lock into that into the ears on the shell. And that's the way it should look when you're done.
There's not, what you're saying then is that there's not a lot of rotational spring load on that when you assemble it.
No, no, and if you put, if you back that thing around all the way around, you could potentially break it or put enough stress on it that it could break after, a few starts. And you should only have to turn it, like I said, 45 degrees. After you have the impulse coupling on, and you guys especially that have, anybody in here that has 4000 or 4100 series mags, at some time when you're going to have to change it to the 4200 series, do not use the nut and washer off of the 4000 and 4100 series mags on the 4200 series. It's not the same. And we have a tag on our magneto on the 4200 series that it's marked important, and it's in, I think, yellow or something, and tells you not to use any other nut and washer. The reason for that is that it's not the same, and it does not allow you to get the proper torque on the impulse coupling. And it leaves a very small, but it leaves enough room between the washer and the impulse coupling that the impulse coupling could move on the rotor shaft and seize up. And if we get a 4200 series mag sent in and it's got that nut and washer on it, warranty will not be honored on it. So it's very important that you make sure you use the proper nut and washer on the 4200 series mags. After you get the impulse on, you might just flip it through a couple of times. If you want to have a lot of fun, just have somebody you don't like grab the end of it. See if it works. If you have a mag and you flipped it through a couple of times and you put it on the engine and it doesn't work, don't necessarily assume that the impulse coupling is good. Okay, it could very possibly work in a static situation like this where you're just flipping it through and you get it on the engine and for some reason it won't work. There's a lot of factors involved, the gear alignment and everything else. So if that should happen, just, don't assume that just because you flipped it through that the impulse is good. It could be bad. When you're installing the condenser into the frame, it's important that you turn the lead with the condenser. That lead is only attached to that condenser with a couple of drops of solder. And if you don't turn that lead and you let that lead get hung up inside the frame, it'll break off, or it'll break enough off that it'll short out after you get the mag on the airplane and you've got, maybe 50 hours on it or something like that. So make sure that you turn that wire as you turn the condenser. I'm not real familiar with the cowling situation on the long easies, but on the Sonorize and some of the other home builds, we have had a big problem with heat. And what happens is there's no ram air or any kind of ventilation getting to the mags. On some of the applications, they've got them jammed back in the firewall with a coffee can. I don't know if that's the same on the long easy or not, but
Dave, would you speak to that for a moment?
Say again?
Would you speak to that? What kind of cooling we get back there?
It's totally stagnant as far as airflow is concerned.
Okay.
It's part of a positive pressure plenum that exists around the baffling. There is no flow established in that area, not by design at least.
Well, but it's on the inlet air and not the heated outlet air either.
Yes, but since it's not flowing, it could easily get a lot warmer than ambient air.
Well, Route 10 always likes to point out the fact that we don't have a heat problem on the accessories. Because of the fact that
You probably don't have the problem that they have on some of the others where they use Volkswagen engines and that type of thing. The problem that we've noticed is that these things should be kept under 150 degrees. And if they get hotter than that, they may run, and then you come in and you land and you shut the thing down and it won't start again. And the reason for that could be one of two things. One, you could have burned the coil up, or number two, and mostly what happens is there's some dielectric liquid in this condenser that is actually it's not a liquid, it's a solid, but it gets hot and it liquefies. And once it's liquefied, it won't work, and the condenser is shot. And we've had a lot of cases on, and I'm quoting the Sonorite particularly because we've had a lot of those, where they'd have maybe 40, 50, some of them as many as 80 hours was all, and the mags just went out on them. So they have done some blast tube and that type of thing, modifications to the cowling to try and cool the mags. The one thing they haven't done yet, and we're trying to urge them to do, is not just an air inlet, but we need an exhaust as well. Because now all they're doing is putting air pressure back there on the mags, and we really need an exhaust back there.
Something for static after the engine's been shut down?
Right.
Any particular area to direct the jet on?
Pardon me?
Any particular part of the mag that would be best to direct?
I would say the best part that you would want to direct it to would be this area, which is the small half of the mag, and down, you know, right as close to the center of the mag as you can, or where the two parts seal. Because right in that area is where the coil, the rotor, and the condenser are located. Heat doesn't really bother any of the other parts. It's just those, you know, those basic parts that get excessively hot.
Don't they mostly get hot after shutdown?
Yes.
Have you specifically had problems with long, easy buildings?
Not to my knowledge, no.
There are a lot of them out there.
No, like I said, we've had, basically the ones we've had problems with are Volkswagen engines and so on. The ones that are using, you know, certified aircraft engines, we haven't had much of a problem. But it is something to watch out for. If you do have, you know, if you do have a problem with a mag and you can't figure it out, check that out, because basically that condenser will be the first thing to go.
But you had a little vent above the mags in the column. Would that affect the Q across the engine very much? You had a little leak above the mags?
I'm sorry, I didn't hear the
You
question.
had a little leak above the mags so that hot air rising after shutdown would just get out. Would that be too much of a loss in the high pressure, the low pressure area in the column? So that's the high pressure area that gets up into the accessories.
Mm-hmm.
Do you think if you drained a little bit of air on top of the mags, that would help?
It would probably help, yeah.
And would it hurt the pressure differential?
They just jet bill. There's no way you'd know that. Do you try
I
it?
don't think that.
I don't think there's any problem on the long end.
No, I don't think you guys have got, like I said, the problem we've had is the Sonorite. Now they have fixed it, but it's still a potential problem because there's no relief for the air pressure. And as you know, as most of you guys know, we have exhaust that come out of these mags with an ozone type buildup, and that stuff needs to be exhausted out of the engine cowling, and just by putting an air pressure in there, it doesn't give it any air flow. It basically just blows cool air in there, and then it becomes static again. So it's just something to watch out for. Like I said, we haven't had much of a problem with the long easies, but you know, if you're ever building anything else and you run into that problem, that could very well be the reason why. If any of you are ever timing the magneto, on the T100 toolkit that we talked about, on the bottom of the toolkit is our timing indicator plate. And you can internally time the mags with this toolkit. This is a close-up shot here. You can see all of the indicators on that plate. Take a look on the chart. There's a chart in the green manual that tells you what to set this at depending on the mag that you're working on. If you're doing a 4250, which is a mag without an impulse coupling, there is a timing plug included in the kit that you can use in place of the impulse coupling, so you've got something to fit down into the slots there. If you're doing any other magneto, because all the rest of our mags have got impulse coupling, do not use that timing plug. Use the impulse coupling. Probably one of the most, probably the biggest call that we get back at the office is somebody timing a 4251 and they can't get the points to get set right. And we ask, we have a number of questions that we ask to find out if everything's being done properly. And we have, in the last couple of months, made this our #1 question: are you using the impulse coupling? Because we find 90% of the people that call in, they can't get them timed, are using the plug, and it won't work. So be sure that you use the impulse coupling when you're timing a mag that uses an impulse. Basically, all that's involved on the kit is to swing the mag counterclockwise. Down in the bottom left-hand corner, you can see a black post there. Swing the mag up against that post. And hook a timing light up, and I'd show you the timing light, but it's our competitors. We don't manufacture one any longer. Some of you may have some of the old ones that we did manufacture, but we don't make them anymore. But we do recommend Bendix's timing light. And just hook up the timing light to the points, set the points or adjust the points until the green light or red light, whatever type of timing light you're using, just starts to go on. Now there are, evidently, from what we found in the last year or so, there are some timing indicators on the market that work just the opposite also. So check to see what kind of a timing unit you have. Then it doesn't hurt to check the points. Our gap setting is 8 to 10 thousandths on our points. Also, I should say here, we do not recommend cleaning our points.
Any particular reason why?
Because of the material that we use on the points. Bendix, for instance, recommends using a business card and just brushing through it. That will work for you guys, if you guys want to do it. But we don't recommend it to FAA repair stations for cleaning the points because of the fitting that goes on in the points. They're just required to be replaced. When you're ready to put the mag back together, as far as lining everything up inside, the only thing you have to do is take the rotor gear, which is a small gear, and line the indicator up to the coil strap. Again, it depends on the type of mag you have. This happens to be a 4251, which is a left-hand rotation. And you can see we've got the L lined up with the coil strap directly above. And then you can see the timing pin inserted there in the, again, in the left-hand indicated hole. And turn the gear, which is the big gear, the distributor gear, until that timing pin falls into the hole inside that gear. If you're turning that gear and you bump up against something, pull the pin out, like about halfway, and turn the gear about 1/4 of an inch and drop the pin back in because you bumped up against the electrode arm. Don't keep turning the gear with that thing bumping up against there because you could work it loose enough to the point where after a few hundred hours, the electrode arm will wobble around inside there. So be very careful that you don't bump that electrode arm too strongly. Basically, we don't see much of a problem at this point. Where we see the problem is when they're timing it to the engine and you've got a lot of pressure, with a prop and that type of thing, and they bump up against that electrode arm, it's enough that you could knock that thing loose.
Do you have a photograph there of the electrode arm?
As far as putting it on the engine?
Just something where we could actually see what it looks like.
No, I don't. You mean the electrode arm?
Yeah, itself.
I brought one.
I don't believe I did. Did you? You got one, huh?
Yeah.
Okay. We can take a look at that one then. I don't have a slide of it now. And just attach the lead and put the mag together. You've got everything lined up and it's ready to be mounted on the engine in time. Now, I won't get into timing it to the engine too much because that is an area that we leave up to the engine manufacturers. And the reason for it is because different manufacturers have different ways of mounting them and timing them to the engine. And once it gets to that point, that's something that they call out in their engine maintenance manuals.
Almost everybody's going to be using light combing as far as I can tell. Is there something we should watch for or anything like that?
The only thing I'd watch for on the light combings is the gear alignment. And as far as timing it, it's, you know, it would be the same as anything else, but I would just watch the gear alignment on the light combings. On the housing screws, again, make sure that you've got them torqued down properly. 18 to 22, I believe, is the torque on the housing screws. You'll notice on mags that you get from the factory, rebuilt and new mags, there'll be a little bit of orange torque seal on one of the screws. That's only an indicator to us to let us know if the mag's ever been opened up. If you get a mag and it has gone bad and it's under warranty and you've opened it up to see if you can, you know, just replace the condenser and get the thing flying again, you find out you can't, you send it in, we will not deny a warranty just because the mag has been opened up. But it does give us some kind of indication as to what's happened to the mag. Well, that box is backwards, isn't it? I'd like to talk just a few minutes about our harnesses. As I mentioned earlier, we manufacture virtually every part that goes into our harnesses. We manufacture the distributor caps. We also manufacture caps for Bendix mags, and we make harnesses for their mags as well. We have a bit of a unique feature about our harness that is of particular interest to home builders, and that is we have a coiled center conductor that we use inside our wire. And Bendix and the other harness manufacturers use like 7 strands of wire. And the difference between the two is that our wire is very flexible. You can take our wire and actually tie it in a knot, or take it directly out of a spark plug and bend it back as far as you can bend it, and as long as there's nothing rubbing on that harness, it will not break down internally. So that is why you never see any elbows on our harnesses. We have a few FBOs and customers call us and they feel like we're ripping them off because we don't include elbows on our harnesses. Well, that's the reason why, because we use that center coil conductor and there's no need to use elbows on a slick harness. Our harnesses come a few different ways. This is a custom harness. We also sell universal kits. If there should be an application, particularly helicopters and that type of thing, where we may not have an approval, we have a custom kit that's approved, and a guy can build up the leads himself. All he has to do is, you can see the spark plug ends are built up, and all he has to do is install it in the cap itself. This is a custom kit that is specific to the Bendix dual mag. We introduced this in 1983, and as I said, it's approved for all 4. This particular one is for a 6-cylinder Bendix dual. And then we also sell individual leads. If you should have one lead go bad, you can buy one lead and replace it in the cap. You can see there's excess hardware there. There's hardware there for both the slick and the Bendix. So you can buy one lead and know that you've got everything you need to install it in the cap. One of the things that I'd like to touch on this evening that is not maintenance oriented, but it's a program that we just introduced January 1st. And there's a copy of the flyer in the green manual that's available there on the table. You'll notice on this particular engine there's a slick harness and Bendix mags. And that's just to show you that we do manufacture harnesses for Bendix mags. For instance, on Lycoming 540s and that type of thing, we do not have mags approved for those engines. But we do have the harness that will fit the Bendix mag. And here, very quickly, I just wanted to show you the flexibility of the wire. Now, the program that I've mentioned is a rebate program that we introduced back in 1981. Starting January 1st of this year, we doubled the rebate. And what it involves is, if you have a Bendix or an Airborne or any competitive system on your engine, and you convert to a slick system, you send the old system into us, we issue 4 credit through your distributor for the $100 a mag, 4 credit, and then we also cut a check direct to you on a 4-cylinder engine for $90 and on a 6-cylinder engine for $100. It's our cash rebate program that we've introduced to try and convert in the aftermarket from some of the competitive products. Some of you guys may go out and buy old engines and that type of thing for use in your long easies. I'm sure you'll find quite a few of them with Bendix systems on. And if you convert to our system, you can take advantage of that program. Now that'll end July 31st, but there's a complete flyer in this manual that you can take a look at.
For your information, we have to do, we don't have room for the Bendix.
That's what I understand, yeah. Yeah, so you guys can really take advantage of it.
Are you talking about a system or an individual mag?
This could be anything. There's 5 different options. You can convert a whole system and you'll get the 90 or, well, we'll talk 4-cylinder, you'll get the $90. If you convert one mag, you'll get $30 plus the core. If you convert a 4-cylinder harness, you will get $30. There's no core on the harness, but you get the $30 check. And there's 5 different options called out in that brochure of how you can get the rebate. And of course, the rebate will vary depending upon what you do. But we do pay a rebate for just about any kind of conversion that you can do from a competitive system.
If you just switch mag and harnesses, and you would get the mags.
You'd get $90, right? Right.
What altitude's that wire good for?
That wire, we have just redesigned the spark plug-in, and that same harness, with the exception of an O-ring on the cap, is used on the Mooney 231, and they've had those up to 25,000 feet.
You mean you have to put the O-ring on if you're going to do that?
Yeah, and you could do that if you want to. I mean, the O-ring's sold separate. It's no different than any other harness. With our mags, you just slip the O-ring in there, and it goes right in the cap as you put it onto the mag. We beefed up, because of the Mooney, we beefed up the spring tension and that type of thing on the 3/4 inch spark plug-in. And we also redesigned the 5/8 inch. Now the 5/8 inch has not been up to 25,000 feet, but it's of the same design except that it's not an all-weather plug. The 3/4 has been up to 25,000 feet.
That's equivalent to the old military stuff.
Yeah. And it's just one last shot of the T100. And that's the end of the slide presentation. And I'll answer any questions that you guys have, or comments or problems that you've had with the mags or anything like that at this time. Just we can.
You mentioned a couple of types of mags, including the throwaway series. Could you maybe just go through the whole series of mags fast and give us an idea what the differences are?
Sure.
John, why don't you come up here and in the
Okay.
front, and Don, could you open the door and see if the door...
Getting a little warm in here. Hey, you want to grab that box, that cardboard box on top of it?
The mags that we talked about, the old case mags, have any of you ever seen them? Sure. The old case mags that were used on aircraft, I'm sure some of you have. And then we went to the 400, 600 series, which was a real big unit. And then we condensed them down into a smaller unit, smaller in size and smaller in weight, which was a throwaway mag. That was the 4000 and 4100 series. The 4000 was the original. And what that was a sealed unit that sold for $50 or $80, something like that. When it went bad, you took it off and you threw it away and you put a new one on. And in 79, well, about 75, they came out with the 4100 series. And there were a few design changes to it, otherwise it was the same identical mag. And in 79, they came out with a 4200 series. And that's a rebuildable, field repairable type mag. There are some people, there's a guy in Florida that advertises in Trade-A-Plane, rebuilt slick 4000 and 4100 series magnetos. And he can't do it because when we came out with the parts, first of all, you couldn't buy the parts for those mags. We weren't allowed to sell them because it was not a mag that could be repaired or rebuilt in the field. Secondly, when we designed the 4200 series, the FAA put a stipulation on us that we had to design it so that you couldn't take the parts from that mag and put it in the old mag and use it. And so we contacted the FAA about him, and they went down to see him. There isn't anything they could do because he doesn't ever mention for aviation use in his ad. However, he does advertise in Trade-A-Plane, and they put out a directive to AMPs that they should not install any rebuilt 4,000 and 4,100 series magnetos. So I should warn you because it's very attractive to home builders. You know, for 80 bucks, I think is what he was charging, you can get a rebuilt 4,000 and 4,100 series mag. You can still buy some new though, and there's some pretty good prices on it. I've been into some dealers and some FBOs, some distributors of ours that still have them on the shelf because most people don't want them because they want the new ones.
How are they size-wise compared to the 40?
They're basically the same size. The only difference that you see physically is, see these little ears on the side? That's the 4,200 series. The 4,000 series is basically the same design, except it's flat on this side. It didn't have a data plate. It was embossed in the side, all the data information. So that's how you can tell the difference. We will take those in as cores. They're worth 100 bucks when you buy a 4,200 series. So don't just throw them away because they're worth some money. And, pardon me, we just scrap them. The reason we take them in is because there's still a lot of them in the field. And it really hurts a guy when he's got to go and buy a $295 magneto if we don't give him something for that old core. So we've just implemented that program to try and get them out of the field and try and keep some of these guys down in Florida and some of these other places from selling them and advertising as rebuilt units. But we just scrap them.
What do they do? Just second source parts for those rebuilt ones?
Yeah.
Who knows where?
Yeah. Yeah. We sent for one of those mags under an alias, and all we got, actually he sold a kit. It was a rebuild kit for 4,000 series mags, and all it was a tube of cam grease and a set of instructions. And that's all we got. And it was $30 for that kit. So that, I just want to warn you guys that we don't authorize it, and if somebody tells you that they're going to sell you a 4,000 series rebuilt unit, be very wary of it. Now you guys can do what you want to, on the home builds. And I'm not saying that you can't put it on, but I'd just be very cautious about it. Take a good look at the mag. Take the harness end of the mag and physically grab the distributor block and see if you can wobble it inside the mag, number one. Number two, check for any kind of gray or brown dust inside here. If you've got either one of those two, that mag isn't going to last 100 hours. So just look for a couple of things when you're buying those. Like I said, you can still buy them, and they're brand new from the factory. There's a guy down in Albuquerque, or in Phoenix rather, Cutter Flying Service. He's got about a dozen of them down there, and I'm sure that there's quite a few of them in other places.
How many hours should they be good for?
Those mags are rated for 900 hours. The new mags with the maintenance, and I should mention the maintenance intervals on these, with the proper maintenance should go to the life of the engine. The maintenance intervals on the new mags, every 100 hours you're required to retime it to the engine. Every 500 hours you're required to take it off, pull it apart, and visually inspect it, set the points, and replace any parts that you see that are going bad. Now, we talked about that service bulletin 783. If you elect to just repack the bearings, then that 500 maintenance interval goes to 250 hours.
What do the new mags cost?
These right now list for $295. That's an exchange price.
Oh, I was just going to comment that I've overhauled Bendix mags. The procedure is basically similar, but it took me about 6 or 7 mags.
Okay.
Luckily that was in school before I really got the technique together. Basically with a toolkit you're selling, you can do the work yourself. But would you recommend to somebody who doesn't have any experience to just take a shot at overhauling it with the manual toolkit?
I mean, if it were me, if I were a home builder, I'd do it myself. Because I think you'll find that that our mags are much simpler to overhaul than Bendix's.
Bendix are tricky.
Yeah, they have quite a few less parts, and there's no E-gap to set on these mags.
Now the
you
cautions,
set the gears and they're all set. They're
the cautions with the nut to be used and the little cautions, that are they all in?
That's all outlined in here. If you take this manual and go step by step, you should be able to do it.
What are they charging for rebuilding in the shops?
If you rebuild them, that's something that you should be aware of. If you rebuild them and replace all of the parts that is required in here, if I can find it, to be replaced, it's going to cost you more than it is to buy a new mag, to buy a rebuild. However, on home builds, you guys can replace whatever parts you feel you need to replace. That's why I suggest you take a look at it yourself. and test, you know, if you can test the coil and condenser, if you have a facility where you can do that. I don't know, you know, if you do or not. But I will warn you, if you have to replace all these parts, just buy a factory rebuilt mag, because you're gonna save over $130.
What are the rebuilds run?
That is the rebuilt price.
$295?
Yeah, I don't even quote new mags because there's really no reason to buy a new mag. The rebuilt mag has basically all new parts in it. We talked about all the parts that we manufacture that are new. It's less expensive for us just to manufacture those parts new than it is to take and, you know, tear down the mags, clean up all the parts, go through inspection, stamp them, because the parts can only be reused 2 to 3 times depending on the part, and then go through another inspection after they've been cleaned and everything else. We just soon rebuild, you know.
It's the old housing with all new parts in it, it's a new mag.
Yeah, basically. We reuse some impulse couplings, some frames, some housings, and some of the rotors, and that's about it. All the rest of the stuff just gets scrapped.
And if everything gets tested out as okay, it's usable? Are there service hours or?
There are, no.
And
The
you don't know the
only thing
history
that
of
we
the-
recommend is overhaul of the engine. And there are service specs right back here. Okay.
What is the new price, just so you know what the difference is?
Let's see, I think the new on the 4251 is about 4 1/4, something like that. It's about $20 more than the rebuilt price plus the core.
That a piece?
Yeah. Yeah. We encourage a rebuild, you know, because we get the cores. It works out good for us because we get the cores back.
My engine.
And of course it's, you know, it's less expensive for a guy to buy a rebuild.
Sure. So all
And
you
it
really
carries-
put into it is the small manufacturing parts.
Right.
And
Carries the same warranty. Everything's identical on it.
What is the one?
6 months, unlimited hours. Now with you guys, we make some exceptions because we realize that you know, you buy mags when there's a good deal, and sometimes they'll sit for a year or 2, or sometimes even longer before you actually put them on. And what we'll do in the case of home builders and that type of thing is 6 months. That is 6. There's a need for that. This is the first time I've heard it. Maybe it's something we can look at.
Well, motorcycles have been using them for years, I understand. Combine the generator and magneto is a common unit.
It's something I hadn't heard about. I'll mention it to engineering when I get back. We've never had it brought up to us that I'm aware of.
When the ultralights go IFR, you really need.
Come on now, we very easy people need it now. You can't afford to carry around those 10-pound coordinators.
Not much of a demand for it.
Are there any other questions or comments?
What's the turnaround time and stuff? What's it take if we ordered one today by phone? What's the back order?
Well, in that packet that I handed you is a list of our distributors. You can contact them. Most of them, they better have it on the shelf. If they don't, their orders to us run about 4 weeks. And we have a backup inventory there that if you have an AOG, it'll go out the same day. So there's no problem with AOGs. We have a 4-week lead time to our distributors to try and get them to keep the stuff out in the field. But when they give us a stock order, we quote them a 4-week lead time. If they put a rush on it, we'll get it out to them within a few days.
And this cash rebate offer is through the distributors?
Yeah, how that works is when you take the old system off, you box it up, send it into the distributor that you bought the slick from, and then he attaches an invoice from him to you as proof of purchase, mails it back to us, and then we issue core credit through him on his account, and then you'll get core credit from him. We send the check direct to you. And we try to get those out within 2 or 3 days after we get them. The only holdup would be if I'm out on the road. I can't get into approve them. Otherwise, they go out within 2 or 3 days.
How complete these mags have to be.
Yeah.
Are you familiar with a mag shop named Aero Mag at Orange County Airport?
No, I don't believe I am.
Okay.
I probably should be, huh?
What's the one in Van Nuys Airport?
No, they're in Orange County.
There's one in Van Nuys Airport. Do you know the name of it?
No, I'm going up there tomorrow.
Right near, about a block away from.
You mean the one we went to?
Yeah.
Aircraft Spark Plug Service.
Aircraft Spark Plug Service.
That's an ad.
I hadn't heard of
They
that one.
rebuilt my mags once.
Screwed
Did
it
they do
up.
a good job?
No.
They gave me it back with the impulse coupling inoperative.
Oh, is that right?
Yeah, and I bolted it on. And,
I might stop in to see him tomorrow.
Aircraft Spark Plug Service.
Okay.
and they ain't
Van
cheap.
Nuys.
All right.
People
Yeah, I'll be up there tomorrow, so I'll stop in and see
Yeah.
him.
You can get rebuilt spark plugs there for $2.25 a piece.
Where are they?
Is that right?
Yeah, reconditioned.
Your choice, huh?
They're a
Real
block
good.
this side of Sandbell.
Are they as good as the mag work?
One of the distributors are
I've
located
put
on Long Beach.
4 sets on Sand.
Okay, we have,
Rotate.
boy, we have a bunch
A
of
single
distributors here in
problem,
LA. I
single
think we've got 8.
They look good.
We've got Hagelin, down in the Long Beach area, we've got Hagelin, Aviol,
They take your
Van
plugs and
Dusen,
recondition them,
Standard
and
Aero,
you can buy another set.
Superior Air Parts. Then up in Van Nuys, we have Standard Aero, Aviol, Van Dusen, and I think that's it. So I think we've got 7 or 8 here in town.
Is there a good man around here that can look at something for you and tell you what you've done wrong or what is broken or?
There's really only a couple of FBOs that I'm really familiar with, and that's like Lynn's down in Long Beach, and I'm really not that familiar with the work that they do. I would recommend talking to a distributor about it. You know, they would know, they're more familiar with the FBOs around here than I am. I could recommend a guy in Chicago, but. Any other questions?
Got a few more slides. Eric?
Thank you very much.
Thanks for your time. By the way, there's if any of you are interested, I've enclosed an order form for the maintenance revision service. I think it's $30 or $35 a year for all the revisions, and it includes service bulletins and all of our promotional literature and that type of thing. So if anybody's interested, you can fill that out and mail it in.
$20
So we can call and ask
Then
about
the first person to buy a toolkit might consider sharing
Yeah.
it with the club and we'll add some money to
You might
the kitty or something.
write the name of Bonnie Gunderson down, because she handles a lot of those calls when I'm away. Yeah.
We'll practice here.
She's in the office all the time, so you'll be able to reach her. Okay?
Longeron's relatively level to the ground, roll out on a takeoff. And think about how you set your axles up to get 0 toe in or a quarter to half a degree toe in. The way the book calls out, you will have more than 2 degrees of toe in if you set them up the way the plans call out. Because your gear, in light of the fact that they are swung forward, as the axle position swings out, you get more and more and more toe out. So if you don't set your axles up parallel, in the condition that the aircraft will be rolling with weight on the wheels, you will be fighting a toe-in condition, getting worse as you take off. So we splay the gear out to the level condition, bondo blocks of wood onto them to get parallel relationship that's in line with the axle, and tack them on. It goes very, very quickly this way, and we're absolutely sure that the axles are center on center in the condition that it will roll for takeoff.
You say you spread the main gear out?
Yeah, with
Upside down.
Yeah, upside down.
I'm gonna try it out.
How much was the spread on that, by the way?
This is making up a pirating a mold from the Sanders cow. Say again, Dave?
How much was the spread on that gear?
I'm not sure, but in pounds, it must have been about 700 or 800 pounds of pressure required to spread them, or more.
Is that how you designed it, just by figuring out lateral pressure that's equivalent to a vertical load?
No, we just get the axles in the relationship that they'll be in when they're on the ground, which is level.
That's the use of tin foil on tapes for the new members. Essentially, if you lay up your bid tapes right on tin foil, cut them out with the tin foil, fold the tin foil to the desired 90 degrees, and lay it up in there with your fingers, in this case with your gloves, and smooth it out with the tin foil on, and then essentially peel back the tin foil carefully, and you end up with a bid that goes in beautifully, goes in easily. It's very dry. I mean, it doesn't have a lot of air behind it, and it doesn't become a mess. Those who try it the other way, you end up with a mess all over the place.
Don't lay the tapes up as tapes. Lay them up in large sections and trim them to exactly the size you want them. You'll have tapes that have nice, clean, sharp, straight edges.
Somebody told me this 2 years ago.
Read your plans.
That shirt is now 2 years old.
This is my airplane upside down. after removing a 13-inch NACA duct and replacing it with a 15-inch wide Herb Sanders NACA, which we also had notes for. What?
Did that make a significant difference in your cooling?
I will know soon.
Oh, okay. We will expect further report.
Yeah. This is a hot-wired landing brake made of polystyrene styrofoam.
There's something in the Squadron 1 newsletter about not using green foam for that landing brake. It's coming out in the new CP.
This is a long easy. It's been carved with more curvature in the belly than what we normally see. And if you look at the hinge, you notice what has been done to get it to work. It's flush with the belly at the ends of the hinge, and quite a bit below it through the arc of the belly.
For the new people, these photographs have all been taken in a hole in the wall. It's a club of 5 builders now, up here on Santa Monica Field.
That wasn't a hole in the wall, was it? That was my shot.
It was your shot.
That was me.
The old shot. Yeah, you're looking at the shoe.
You're forgiven.
It's my shot.
Roving camera.
This is Jerry Sloan's airplane being flown by Mike Melville. Has a Herb Sanders cowling and long winglets on the canard and an extended nose.
Tell us about the lettering. I saw some lettering yesterday, the day before.
Computer cut at Herb Sanders, by GTE. This is fun and games on Saturday. This is a mistake.
So Dave is testing this now to mount on his wings. He's got a little button, a little micro switch in there.
This is his last longing tank.
I know, that's what you're doing, Dave. Don't tell me you're playing nuclear warhead. Complete with IR guidance on.
You know, there's nothing more demoralizing than buying your strakes out of task and having 3 long units take off and join up in formation.
This is Sam Hale's airplane. This is my airplane. Sam's again. Melville's panel. Jerry Sloan's panel.
Burl included.
Wow.
It's Jeannie Yeager's airplane, or Dick and Jean's. These are shots taken from the back of her airplane. This is underneath mine. Again. Mine again. This is the middle of a roll.
I hope so.
It's diving under. This is the completion of the roll coming out from underneath the Tiger.
Now he's about to fire on the Tiger.
Here's the hole.
What's the hole in the cloud of the roll made?
Down them in the
Burst of the
Palisades.
bellies. That's Edwards in the back. Gina's airplane in the front, Dick and Gina's, and Eric with a video camera way in the back, and a Grumman.
When are we going to see the video?
We've got videos of all this stuff.
You saw some of it last meeting.
Pretty snuck down in the parking lot with no windows.
That's right. This is
No,
the Watson
you're right,
Bill. This is that's Dick's new nose, I believe.
That's blue.
No, Voyager inside. It's got blue tones to it. Very little paint. This is the landing at Compton. You went the first time? It was a little close, yeah. This is just above Camarillo, near
Hidden Valley.
Lake, Toluca Lake, I believe.
Oh, Hidden Valley.
Sure.
One of the prettiest drives you can make when you're bored with film.
What would be off to your left? This is Jan Van Oor doing his famous pull-out at Santa Monica Airport.
Go around.
His low,
Before the
his low
gear
pattern. Come on.
Now, if you set the toe in like the original shots you had, according to the plans like I did, will I have too much toe in?
You'll have more toe in than you want.
And does that mean it'll be a longer takeoff roll, or what will that mean?
It will extend your takeoff roll and it will wear your tires.
And how do you fix it?
You attach a pair of 2x4s to each wheel, tie ropes around the 2x4s, which pins the wheel. And now you've got a point from which you can pull one end of the 2x4s. You do them on both tires. You just pull them, flex the gear, and then heat it up with an industrial heat gun until the landing gear yields. Until you guess at it, actually. Get it to yield a little further, then let it cool. Check your toe in with the weight of the aircraft on the wheels. Like you would at a tire store. They have a rack that the tire goes on. They have a needle that represents 90 degrees to the center of the axle, which in this case is a board on either side of your tire. And then you measure the difference between the distance from the front of the boards to the back of the boards.
How about taking it over to Bear Liner and running out?
Why not? Has he got an industrial heat gun to change your toe in?
No, you take one with you. He's coming to the door.
Turn left.
Why does he not just shim the axles that are on there? Change the toe end with the way
Well, if you ask Bert how to change the toe in, that's how he'll tell you to change the toe in, without changing the axle.